You can start.
Okay. So, hi everyone. My name is Durand, but I think Alex told you already this. I don't understand Russian or Ukrainian, unfortunately. Thanks for the invitation, Alex and Igor, and thanks to everyone. This is a full room. Today I'm going to speak about APIs and how to write Pragmatic API. Okay. First, who already built an API or at least consume an API in this room? Yeah, raise a hand. Okay. Well, that's quite a lot of people. Among all of you, who think he or she created a RESTful API?
No.
Yeah. No, there are actually a few people. So we will see, actually. So in this first part of my presentation, I'm going to introduce some theory about REST and why it may not be or may be something we know and so on. So REST stands for Representational State Transfer. I think all of you know this already. But basically, it's how the web works nowadays. So if you go to your web browser and go to google.com and type something you want to search, then you hit the submit button, and then the web application Google replaces with a HTML page made of a set of links, right? And these links are actually hypertext links. And then you can click on these links and jump from page to page until you find the content you are looking for. Okay? But at any point you had to figure out how to make a request, like a GET request, to go to this page where there is the content you are looking for. Or you don't have to know the URL of this page, because you only just use the web browser and went from page to page by clicking on links, right? And that's exactly how a REST API should be. Okay? So REST has been formalized by Fielding as a set of constraints, and there is this guy, Leonard Richardson, who created a model, the RMM, which stands for either Richardson Maturity Model or REST Maturity Model. There are 4 levels, 0, 1, 2, 3, and basically if you are not at level 3, then you don't have a REST API. Okay, you only have a HTTP API, which is fine. So level 0, 1, 2 are actually all about resources, so we care about having proper nouns in the URIs. We spend time designing URIs properly, then we use HTTP correctly, like the client uses the right HTTP verbs or methods to express actions on the server, and the server replies with proper status code so that the client knows what happened on the server side. And there is also this thing, content negotiation, which is basically a way of saying that both the client and the server must agree to speak the same language. Okay? And then there is this level 3. Level 3 is the hypermedia control. So the basic idea is to have relations in the responses to enable what we call service discovery. And that's why I told before that HTML was and the web was a perfect example of a true REST API. Because HTML is an hypermedia format. An hypermedia format is a format that describes this notion of relations. And in this case, we don't care much about resources, but we do care about representations. And I get back to this point in 2 slides. And because of this, we don't really care about URI design anymore. We don't have to choose the nouns in the URIs carefully. We don't care actually. What's crucial is client experience. Because just like a web browser for any web page and web application, the client doesn't have to figure out how to use the API. And this brings to a new concept, the protocol and application semantics. And I'll get back to this part in 3 slides, actually. But before, I had to introduce this term, the 8OS thing, this acronym that almost no one is able to pronounce correctly. This acronym stands for Hypermedia as the engine of application state, and the only thing you have to remember when it comes to this term is that your application, your API, is just a big state machine, okay? And you have transition to switch from one state to another. And that's how your API, your RESTful API should be. So resource versus representations. So a resource can be anything, so you probably all know what a resource is, especially if you already built or consumed an API. But you can have many representations, like in different formats and so on. And a representation is only one thing, because it's one representation is a description of a resource state. And that's why in hypermedia controls and this level 3 of the RMM model, we don't care much about resources, but rather about representations. And then comes semantics. So the protocol semantics is basically how we use HTTP, like having a collection of resources, a collection of data. When you post on this collection, we use a post verb, and we craft a request with this verb, and we do that on a collection. It should add a new item to the collection, right? But that's a sort of convention, because nowhere it's written except in the REST HTTP documentation that we should do that. That's just semantics. And that's the protocol semantics. Or we use HTTP basically. And the second part is application semantics. It's more about what should be sent and why, and what those fields in your or attributes in your responses are. Okay? And actually, maybe this term, application semantics, is a bit scary, because it looks like a computer science thing. But actually, you all know what it is, because oh no, too fast. We'll get back to that point in a second. Because before, I have to introduce this book, The RESTful Web APIs, which has been written by Leonard Richardson, the guy of the RMM model. And if you want to know everything about this book and about REST APIs, right, you should read this book. It's called RESTful Web APIs. And in this book, authors describe the semantic challenge. Like, we have plenty of hypermedia or formats, and some of them are good at expressing protocol level semantics, and others are better at explaining how it works on an application level. But it's complicated to find a format that fits both semantics, that describe perfectly both semantics. And that's where my last concept actually comes into the party. Profiles. Do you know what a profile is? Anyone? Yeah, 1%. Fantastic. So a profile is basically how to add semantics, so the thing we talked before, on a format that is already established, right? And this thing, you actually already know what it is. Like I told you before, application semantics, you know already what it is, even if you're not sure. And that's the same for profile. Because traditional API documentation is a profile, and usually it explains how your API works, so that's the protocol semantics, like which endpoint to use, which HTTP verbs. So that's the protocol semantics in your API documentation. But it also explains why you should send this attribute and this attribute and this attribute in a post request, for instance, or in a put request, or any other request. Okay, and likely you'll have to say, okay, in this payload, when I return the first name and the last name, so first name and last name correspond to names of a user, for instance. Okay, so that's the semantics, and that's the application semantics. So API documentation is a profile, but there are also plenty other formats such as XMDP, ALPS, and so on. And the two last are actually really interesting. So there is the JSON LD, link data. Anyone knows this format or JSON LD? Nope. And JSON schema. Do you know JSON schema? Yeah, cool. So given this, so it's over for the theory. Hope you enjoyed. Let's see if we have REST APIs in the industry, so in real life, actually. Because the fact is we all want RESTful APIs, right? Before, some of you raised your hand when I asked for people who already built a REST API. So if I had to ask this question again, who wrote a REST API now? Yeah, less people, but still, good. But most of the time in the industry, like in real life, what we found is such REST APIs. Can you spot the main problem there? Can you read it? So what's wrong with this Twitter REST API? No, post is fine, I guess. That's just the verb, but right after. What's wrong? Delete. Yeah, it will. Yeah, I get it. But why? Why did you figure out that it should be delete and not post?
Because it's RESTful.
No. Yes, because we have destroyed in the URI, and that's why its status is destroyed, right? And for you, it shouldn't be that way. It should be delete status and the ID. And that's why this is not RESTful, because it's more RPC thing when we express commands in the endpoints. But there, it's sort of whatever. That is not REST. And when we use JSON, the format, only in an API, it can't be a RESTful API because we must use hypermedia formats. And when we don't send relations in our API responses, then it can't be RESTful either because we have to bring this hypermedia links and we have to think about state and transitions. So let's replace most of the REST API out there by HTTP++ APIs, like pretty good API, but it's not REST because there is one fact: REST is complex, and REST is actually too complex for real life, and that's why many people think that we either should not be REST or should do something, that's called REST, but it's not really REST. But today I should say that I didn't see much through REST APIs in real life. Most of them are good APIs, like Pragmatic and well designed, and some of them are future-proof, so they are very well designed, but it's just not REST, because REST is really complicated. And with my previous part on the theory, hopefully you got this point, but it's not easy. Question is, are we all screwed and should we hold on to this GraphQL thing? Answer is
Jump.
no. We shouldn't. We'll get to that point later. My proposal is the pragmatic way of building REST API, and that's why I'm going to explain now. Based on my last 2 or 3 months, this is more feedback on how I built my last REST API. And in this introduction, I have 3 steps to explain how I ended up writing a pretty RESTful API without losing too much time on this theory and on just figuring out what's REST, what's not, and so on. So first part is documentation. You are all, or almost all, PHP or Symfony developer, so do you know something like the API doc bundle? Right, Durand? Good, good. So what you used to do when you write an API is briefly describe a specification about your API, then you implement it, and then you use some sort of tools like the API doc bundle to generate the documentation. That's the traditional way of writing an API or any application, actually. And that's what I used to do before, but for my last project, I actually changed my mind and tried something else. I started to think about documentation first, and then try to build my API once the documentation was ready, and that when we all agreed on the documentation. And for this, I used the API blueprint format. Have you been heard of this? Yeah, 1, 2, good. So API blueprint is a format for describing APIs. It's not only for REST APIs, for any web APIs, and it's basically a superset of Markdown. So if you know how to write Markdown content, then it's easy to write API specification. Especially if you use a tool like Apiary. Good. Apiary is a web-based editor for writing API blueprint specifications. And so on the documentation side, you get on the left the documentation in human readable format. And if you click on any action, then you get some realistic requests and responses so that you can know exactly what the API expects and what the API replies. If you don't want to use a tool like Apiary because it's a web product, even if you can do everything for free, you can use Alio. That's the same, but you can build your documentation locally and have themes so that it can fit with your templating and so on. But what's interesting about API doc is not really how to write documentation and to build this documentation page. What's interesting is what comes with such format, like a mocked API. So on Apiary, if you write your documentation in Apiary, you get a mocking API for free. So you get a realistic API based on your documentation. And you can also use Dracov, like this. Can you read this? Yeah? Or maybe you can switch there. So this is the same thing here. On the left, I have this Dracov thing. And on the right, I can make an HTTP request. And I get back the response I described in my API blueprint specification. And it's served by the Dracov API, so that I don't lie. I mean, it's not a request made on the real API. It's on the documentation. And that's really cool, because you can iterate over your documentation until you reach consensus and until everyone agree on this specification. For our project, I gave this thing to my coworker who did the client-side application, and he could write the whole client-side application in JavaScript with only the mocked API. which is really nice because at that point I have a pretty realistic API, but I didn't write anything. I mean, any PHP or any code. And the other thing that is really interesting with the API blueprint is the support of mzone, a way of describing a payload, a JSON payload, but in a more Markdown YAML-ish format, like there. And then you get JSON schema for free. Automatically generated. So on Apiary, it's part of the right panel, and you can also extract this thing and then share this schema from your API. Remember this notion of profile before? We get that for free. The other thing we used to use for API documentation is the Open API initiative, formerly known as Swagger. Anyone about Swagger? Do you know it? I actually stored the theme, the template of Swagger when I wrote API doc bundle. That's why it looks like it's Swagger, but it's not. And so in Symfony and PHP, we have this API doc bundle, but as I said, it's the opposite approach. Like we write the code of the API and then generate the documentation. That works. But today, I wouldn't do that anymore. And especially because the API doc bundle future is quite uncertain. We don't really know if we'll still continue to maintain this project or if it will work the same way as before. It's in the discussion, issue 900, in case you want to say something. Some people already did some job from the API doc bundle to convert to Swagger, and we have different libraries in PHP like Jane and Jane Open API for both JSON schema and Open API if you want to use these tools in PHP. But basically, API blueprint is generic. The tooling is generic, and you don't need specific tools in PHP. So my advice in this part is to write the documentation first, right? And once you get the doc right, then you can code. The doc should live in the same repository as your code and your API, and you should test your documentation. Like, at least build the documentation so that you don't have syntax errors, and maybe use Dread, but I'll get back to that point later. So once you get the API doc right, you can code. So in Symfony, we have plenty of tools like the Symfony REST edition. Have you heard of it? Symfony REST edition? No? Yeah? The first REST bundle, anyone? Ah, yeah, hopefully. This is one of the most used bundles. So if you combine the first REST bundle and the I2S library, do you know the I2S library? Yeah, I covered. That's fine. It's one of my projects, but that's fine if you don't know it. I don't mind. Then, if you combine both, you get a nice way of writing AL APIs. AL stands for Hypertext Application Language. It's yet another hypermedia format. And there are also other tools like Fractal and Negotiation. Fractal is a serializer in PHP for serializing responses, API responses, and Negotiation is a library for content negotiation. Okay, so we have a really strong tooling in Symfony and PHP. Lately, I'd say a year ago or something, this project came up for nowhere. It's called API Platform. Do you know API Platform? Yeah, me too, actually. I think it's a pretty interesting project, and you should look at it in case you want to build JSON LD APIs. JSON LD stands for JSON Link Data. I told you this already. And yeah, I think it's good because it's not tied to Symfony, but it's really well integrated with Symfony. But it's just a pure PHP framework. relying on Symfony components, of course. It has everything from documentation to Docker and so on. But I didn't use it, so I can't really speak about it much, except that it looks like it's used and more used. But what seems a bit scary to me is that it uses the JSON LD format. It's a really nice format because you can get a RESTful API with this hypermedia format. It's an hypermedia format, and then you can also describe this protocol and application semantics. But to me, it's too much and too complicated. That's why I like to talk more about the JSON API format. Anyone? JSON API? Nope? Great. At least I'm here for something. The JSON API is yet another hypermedia format. And it's really close to plain JSON API, like non-REST APIs. But this is actually a nice way, to me at least, to write RESTful API with a JSON. So in a JSON API, you get this data primary object and a set of links. You at least must have to send an ID and a type for any data, and that's it. Then you can use get as you used to use get for fetching collections or resources. You can use post to create new data, and you can use delete to obviously delete data. And that's it. The attributes thing is where you should put the data related to a type, and then if you want to create a RESTful API, you have to provide some links. For errors, it's just an array of errors, always the same, and that's it. You almost know everything about JSON API, and that's why it's a great format, because it's really easy to grasp the basics, because there are no much things for making a JSON API. The only difference is how to update data. We don't use put, but patch. A while ago, I wrote a blog post about about using patch the HTTP method correctly. And basically, if you know this blog post, you maybe will tell me that I could be an idiot, because it looks like I use patch the wrong way, at least according to this blog post. Because patch should be used not just to replace put with a smaller payload, like just sending only what you want to update. That's not how patch should be used. Patch should be used with a really specific format to describe a difference, like git diff or the patch command on Unix, where you get the line before and the changes you have to make, or the operation you have to make to get the new information. So there are hypermedia format for this, like JSON patch or JSON merge patch. And here it looks like I don't use this formats, but rather stick to API JSON format and send only what I want to update. But that's fine, because it's described in the protocol semantics of the JSON API format. In JSON API, we explicitly describe that the update must use the patch HTTP method, and that the payload, the request payload, should look like this. So it's a data object with an ID, a type, always, and then the attributes you want to change, to update. Okay? So I'm actually not an idiot, or at least not for this. But what's really cool with the JSON API is all the features we implemented, or at least we specified. The first one, I really like it, is the sparse field set. So the sparse field set is basically you use the fields query parameter, and for any type, like the sequence type, you pass the attributes you want to get, and only the attributes you want to get in the response. So in this example, I only want the name of the sequence, and then I get my set of sequence objects with only the name attributes. Then you can use filtering. So it's the filter query parameter. And what's cool with the JSON API thing is that it's very flexible. Like, it says in the documentation that you must use the filter query parameter, but there is no constraints on the strategy. So you can use any filtering strategy you wish. In this example, I decided to use, and for this project, I decided to use the MongoDB querying language. So this part, okay? And then I can combine this with sparse field set, and this query, the get whatever, actually says, give me all the sequences of sequences, because this is a part of biological data, and maybe you're not very comfortable with biology. We all have DNA, and we have sequences of DNA, and it's actually called the same. The sequence and the sequence describing the sequence is the whole type of DNA, but we also have a specific sequence of DNA. This is a representation, so it's A, T, C, G letters for describing a DNA sequence. So in this case, I just want to get all the sequences, so all the A, T, C, G letters of all the sequences where the name contains demo. Alright? You can pass options, so in this case it could be demo with a capital D or not. Okay? Then you get pagination, and it's the same. Like, use the page query parameter, but then do whatever you want behind the scene. And in this case, I decided to go for cursor-based pagination. And this helped me introduce the meta object. So before we had data, we had links, and we can also have meta. And meta is for every optional or additional information. So in this case, I put this page object, which describes all the information for the pagination. And cursor-based is based on, the cursor-based pagination is based on MongoDB ID, and in MongoDB, it's just a matter of saying the ID is superior or inferior to an identifier. So it's pretty simple to build such a pagination strategy. And last is the inclusion thing, with the include preference. So there, you say, I want to include, and you put anything, and at the end you come up with an included property with anything. So now let's think for a second about the sparse field set, the pagination, and the inclusion, and the filtering. If you combine all of these, you can, from the client side, query any data in any ways, and at the end you always get something that looks the same. Like the JSON API stats that you have to return a set of data, and data must have an ID, a type, and optionally a set of attributes. Okay, and that's pretty interesting. And that's why we want to jump to GraphQL right now. Just saying. Another point about this API. So I told you that the API I had to build was about biological thing, and actually the idea was to upload big biological data files and then create an API from this API to expose the data. And creating an API, like exposing all the data for 1 gigabyte file takes some time. So we don't like make synchronous requests. We chose to create a synchronous task. And so in any REST API or any HTTP API, this is always the same thing. We post the data as usual, but then instead of getting 201, so like the created status code, then we get the 202 accepted with a content location. Like actually the API says, okay, I got your request, now I'm processing the data. Go to this content location to get a date, and that's it. So then you can create the upload jobs and so on. Endpoint, you get this payload, and at some point it will be complete, like the task has been done, and you get a 303 response saying, okay, the API has been built, now go to this location and enjoy. You get your data at this location, okay? So this is the RESTful way, but it didn't work with the client-side application. And we faced this point on the documentation step. Like it's totally possible to specify this way of making an API with API blueprint. And when my coworker played with the mocked API, he found that it was nearly impossible to use the fetch method in JavaScript to get the response of type 303. It doesn't work. So even if in the GitHub qualify in JavaScript, it's a one fix. There is an issue for this, but it's a one fix. And in the Chromium bug tracker, it's the same. If you didn't fix this thing yet, and I don't think it will be fixed, to be honest. If I had to if I started to implement the code, then I would have lose time and wasting time because of this. But because we found this bug early with the documentation and the mocked API, we came with a new plan, like a degraded mode for browsers. So we used a prefer header that way, and if you specify with this request, the GET request to get the state of your asynchronous task with a prefer header and status equal 201, when it's complete, instead of getting this 303 response, you get a 201. It's not RESTful anymore, but at least it works, okay? And that's my point. Like, it's okay to be REST compliant, but it's nearly impossible. We saw this before. So JSON API helps you write REST APIs because it's a nice hypermedia format. It's not far from traditional JSON APIs, like just the plain whole HTTP API, but it helps you reaching this level 3 of the resource maturity model. But also, it's important to be pragmatic, and when something doesn't work, you can, we couldn't fix the browser or any other implementation of the fetch JavaScript thing. So we had to take a shortcut, and it's always good to take shortcuts. And so it's fine not to be always too compliant with any specification anyway, especially with REST, because REST is complex. And in this case, I used the JSON schema for the application semantics. It's perfectly valid, and thanks to API Blueprint, it was already generated, like automatically generated. So now, we did this documentation thing, we implemented the API. Now what's the last step? Anyone? When we build an API, so we have the documentation, the programming thing, the implementation. What's the last step?
Testing.
Yeah, testing. Of course, testing. Otherwise, it doesn't work. So the first way of testing an API is to use like the same tooling as everything else in your project. So if you are in PHP and Symfony, you use PHP unit probably and maybe Guzzle. So that works. Like it's a perfectly valid way of testing an API, but it's really verbose. Like you have to write a lot of code. So I wouldn't go for this. You have Biat. I think you know Biat, maybe, no? Yeah. This is a better way of writing tests. Because you can write many scenarios and it's more easier to write text than code. But then there is another problem. You have to write a lot of step definitions to get all these sentences actually trigger, request, or assert things. So it's better to go this way to be more functional or behavior driven, but it's still a lot of work. And my advice would be to actually look at other languages, like in the Node thing. You have this Structuram project, which is designed to test REST APIs or HTTP APIs. So it has everything to write tests without losing too much time instantiating a Guzzle client and so on. Okay? It's easier. There is also Frisbee, so it's nearly the same. It's a tool that is made for testing API. And for the API doc, I told you about Durand before, and here is Durand. So Durand isn't about testing your API, but testing the API documentation. So you pass to Durand your specification, your API blueprint file, the markdown file, and the endpoint to your API, and then it looks at each part of your documentation and try to see if it works. So behind the scene, there are hooks for your real implementation to inject the values, like this identifier is always the same in the documentation, but then Durand will query exactly this identifier. So you have to, your API, your implementation has to respond to this specific identifier. And as you can see in this screenshot, I have a lot of skip tests because it works, but there are some edge cases where it doesn't really work. But at least you can assert that there is no much, there are at least things that work in your API definition. So that's a cool project, and all this API blueprint, Durand, and so on are all of the API thing, but it's all open source, and most of their formats, like the MZone and the API blueprint, are actually open standard, so you can safely run it. For more manual testing, you have this Postman Chrome extension. Do you use it? Yes. Great. I actually found this one 2 months ago, I guess. I didn't know about this. I used to use another tool on the command line, but didn't go for this thing. But it's really nice. So there is also Earl.it. It's like curl, but in your web browser. So it's interesting when you have to share a specific request with your coworker. It's better than trying to copy paste the terminal thing. And of course, the HTTP Py. That's the tool I used to use. It's like curl, but better. This is HTTP Py. So there is curl, but with colors, and it formats the JSON correctly, and so on. Do you know HTTP Py? Yes. Yeah, you should use it. And if you do some curl thing, HTTP is way better. GQ, do you know JQ? For JSON data? That's another thing you should really use if you play with JSON. It's a way of walking through a whole JSON document, but easier. And if you want to use JSON API, because you have to set the proper headers, like accept and content type headers, what I used to do is to put this in my ZSH file, so that I type JSON API instead of HTTP, and then I don't have to type the header that are always required. So let's conclude now. Documentation. For me, it's very important. Hopefully, you are convinced that it's really interesting to write documentation first, because it enables a lot of things before going to the coding step, and you should test it. For code, I love JSON API. Maybe you are not convinced and you want to use something else. The else to me would be to use JSON-LD with the API platform. Before going to this JSON API thing, I was more evangelizing JSON-LD, but no JSON API evangelist, right? And it's okay not to be 100% REST compliant. Okay, that's fine. We all know that REST is really complicated, and you must test your API. And in case it's not clear, you have no excuse for not testing your API or any code. Actually, we can test many things, and especially in PHP, we have probably the best tooling for testing code. There are many things, because we grasp all the interesting concepts in all other languages, and we can have like a whole set of testing frameworks and so on, and it's very interesting. I didn't talk much about security in this talk, because that's another story for another time. I will go for the API key or authorization header or a token, even if the API is public, because at least you can get some sort of statistics on who uses your API, and you can apply some rate limiting things with the token. You don't have necessarily, you don't have to bind this token to a specific user or to have specific rights, but at least it's good to only have, to always have a token. Like for the Google Maps API, it's free, but you still have, and it's free and quite open, but you still have to use a token. Also, OAuth is not for authentication, okay? OAuth is for authorization. I know it's complicated, but especially because pretty much everyone uses OAuth 2 the wrong way, but that's fine, no, because there is OpenID Connect, so it's OAuth but for authentication. And if you go to Google or Facebook API developers documentation, we all switch from OAuth 2 for authentication to OpenID Connect. The Jute, or JSON WT, but I think we pronounce Jute, which is not really nice to hear, is trendy, and I would go for this if I had to authenticate my user. And there is this nice bundle, Lexi Jute Authentication Bundle. Do you know this bundle? Do you use it? Good. And talking about Jute authentication, if you want to be really fast, you can look at Auth0. Auth0 is basically authentication as a service. And we have a nice article on how to integrate Auth0 with Symfony. So if you Google for Auth0 Symfony, then you will get to this page, and it's a pretty nice way to quickly go with an authentication layer without having to spend much time on it. Also, about any question related to GraphQL, my answer would be, I don't know. Okay? GraphQL is nice. I think it won't replace REST APIs because it's different. And I also believe that when we assert things on REST, like it's slow, it's too much requests and so on. It's actually not true. But anyway, thank you for your attention.
Cool. Nice. Who wants to start with the question?
Thank you.
Let me start.
Yeah.
Why do you think that GraphQL is not kind of replacement for RESTful API? As Facebook mostly promoted like replacement. And in our company we try to do this, but not so successful, but maybe you know something.
Well, the main selling point of GraphQL is to enhance the client side or the client experience. Like from the client, you create a graph thing with properties you want to fetch. You pass this whole thing to the server, and the server comes back with the same payload pretty much, but with the values. And if you got my point on JSON API, that's exactly what you want, what you can achieve with JSON API format.
Yes, for basic it's different. I'm not agree with all this, but how to say, it's with GraphQL, they bring absolutely another way how to work with your data. So it's okay. Let's say it's not kind of replacement RESTful API. It's kind of different tools which can be used in the same way.
Yeah, pretty much. But to me, it's like having MongoDB and MySQL or something. Like we can't really compare both because we are not exactly on the same level, right? So the GraphQL is interesting because you send one thing and then you let the server doing everything. But I thought like 10 years ago we stopped doing this because it was too long to process data on the server side. And if you look at GraphQL, but I didn't dig too much into GraphQL, but it looks like you have for each property a method that is bound, a resolver or something, for retrieving the data, and then you have to combine everything. So to me, you stop requesting multiple endpoints in REST to one request, HTTP request on GraphQL, but then the server has to do a lot of work to come back with a response. And especially with HTTP2, I don't think it makes much sense to say REST is too slow because we triggers many HTTP requests. Because with HTTP2, we don't mind. We can send many requests at once and it will be fast enough. So I don't know. And also there is this graph thing in the term. So to me, it's different. Like it's to build a graph on the server and get back with this. I'm pretty sure for Facebook and maybe GitHub it makes sense, but for more like normal projects, I don't think so. But as I said, I don't know.
Okay, any questions? Okay. Я пока ask you one question small. Once again, GraphQL. For me, GraphQL is wise preference because it have kind of flexible scheme. So like we have in NoSQL. So when we have, for instance, huge objects of user, and we can easily modify this to what we want to respond. This is not having RESTful. So we should almost control what we should respond. GraphQL is quite flexible.
Yes, that's true. But then you move all the complex logic to the server side, and it's good to be schemaless on the client side because it's really great for the client experience. But then you have to do something on the server, and I'm not convinced by this. I don't know. I mean, as I said, I didn't dig too much into this thing, but from what I read and saw, I think the server side will be more complicated now. So it's always a matter of trade-offs.
Okay, you mentioned about Swagger, but did you try to create mockery service for your APIs? Or maybe if you didn't tried with Swagger, you tried to create mocks for your APIs with other services. And have you ever tried to create mockery for it before implementation? So you will be able to use already your API endpoints without implementation, for example, for front-end or for mobile programmers.
With which project?
Swagger.
Swagger? No. That's something I forgot to mention, actually. When I started the API doc vendor, the Swagger wasn't in version 1, it was version 0.1 or 2. So that's why I didn't stick to this specification. Then we added the version 1 implementation. And then I stopped looking at Swagger, I must admit. So last time I checked Swagger, it was a JSON thing to write, a JSON file to describe the API. And yeah, I do believe that there are mock APIs with Swagger and
yes,
pretty
I
much
tried,
the same thing.
But to be true, I didn't get good results, so I postponed it a little bit.
Yeah, and
but maybe you tried to create something with another service.
I didn't try with Swagger. I must say. Also, Apiary does support Swagger, by the way. But to me, the JSON description was too complicated. Like compared to plain whole Markdown file that renders nicely in GitHub pages, for instance, or in GitHub repository. And that's why I decided to come up with this format and not Swagger. But yeah, maybe it could be it would be possible to do the same with Swagger. Just for me, it was easier and faster to go with API blueprint. So if to say that Swagger has a mock API, but you didn't get it working properly, so that's a good point for API blueprint.
Okay, thank you.
Any more questions? Oh.
How are you testing your capacity of the API or high load?
For the...
how you know how many rate limits you set up in your API?
How many what? Sorry?
Rate limits. So you before you should check for capacity of the API. How you do it?
There are a couple of tools I've used. A while ago, many years ago actually, there was this Gmeter framework or tool. But then there were other tools, and what I used lately was Siege. Do you know it? And that's how I tested my the limits of the API, how many queries I can get. But for basic stuff, and because my API I actually wrote it in Go and not in PHP, sorry. I use some Go toolings like Go WRT or RT, I don't know, whatever. It's a sort of Apache bench, but written in Go. That's an easy way to send multiple requests from locally, and at least you can combine this with the debugging API in any Go web server, and then you can spot some issues. And for this, as I said, I use a sort of Apache bench or whatever that sends a lot of requests to the endpoint, and then a debug API, which is able to write debug information to files, and then I convert these files, this information to a Flam graph. Do you know what a Flam graph is? No. It's maybe I can show you this actually. I don't know. So this is, by the way, the API blueprint specification. I don't know. No, I don't have it. But maybe I have internet. Nope. A frame graph is used to describe the call stack of all your methods in your code, and when it gets bigger on the horizontal line, it says that it's basically something you should improve or at least look at. I don't think I get internet, so.
Conference 3.
Thank you so much.
Ah, where?
3.
Where is conference? Ah, good. No. Please stop all your phone and. So yeah, maybe this will work. So I get back to this point. But basically, this approach is for looking at your code and enhancing your code, but for simply testing the limits, the capacity of the server and the API. Yeah, I use Siege or Gmeter, but Siege is more interesting now. What are you using actually? Fastpage. Any other question?
Thank you for your presentation. And the organizations said that you don't use Symfony anymore. And I want to ask you why.
That's very true.
What are you using now?
As I said, actually, it's not that I don't use Symfony because of Symfony. I spent some time working on Symfony and with Symfony and for Symfony. So I didn't leave Symfony because we broke up like a relationship, but it's more that I don't use PHP anymore. So that's a different thing. And it's quite unfortunate, I must say. When I was a student, I started with PHP to like for myself, and ended up contributing to Symfony and the ecosystem and all these bundles. And then I had to change. I've been hired to a company for a PhD, and I did a lot of Java and C# stuff, not very fancy. And that's how I slowly stopped working with PHP. And then I came back to a new company, Taylor, and now I work on mainly front-end development with JavaScript. And on the backend, as I said, I use Go, the Google language. Which is, from a PHP developer point of view, one of the most complete language, let's say. Like, the syntax is almost the same, except you can strip all these $signs everywhere, because we don't need $signs anyway. And it's sort of procedural, but it has a nice feature set. So in case you want to move from PHP to something else, Go is a nice alternative, I say. But what makes me sad is that the PHP ecosystem is actually really big. We have many libraries, frameworks, and just with Symfony, it's really good to work on a daily basis on a Symfony project. We have so many tools, and when you go to the Go language, the documentation says it's better to copy paste than to reuse something, and it's better to do everything by hand and with yourself than to rely on any other tools. So we don't have a sort of composer, for instance, in Go. So it's a nightmare to work, and it takes a lot of time.
One more question.
Yeah.
Hi, I have maybe a junior question, but we have next situation in our project. We have API, we write it very well, but at some point, sorry, I'm not public. And at some point, our customers say, we have one method which create one model. And he said, let's say this method will be create, we put more parameters, and this method will be create 5 models, which connected with each other by relationship. And could you help us with arguments for the customer for
Don't do this.
don't ask us to develop bad things.
That's the main problem of any software developer, I'd say, like dealing with clients or customers. But unfortunately, we have to do this anyway. Actually, I don't think it's a problem if you don't call this a REST endpoint. Like there is also this thing, the RPC approach, where endpoint, the URI of endpoint is a verb, like it's a command. RPC stands for remote procedure call, so you call a command. So maybe if you rename your endpoint like create my 5 models, then it makes sense for an API, but it's not REST and not really HTTP-ish anymore, but at least it could be a way of doing this properly. Otherwise, we may discuss this like later, maybe.
Yeah,
I think
it's better to always.
I will be kicked.
Just 2 comments, 5 cents about it. Your problem is about it. If you lose your basic logic, so it means that you move out from the RESTful API, and you move out from RESTful, which not even like Twitter app. So Twitter, as William showed us that even Twitter API is not API itself, so it's a RESTful API. So if you move out from the basic representation from the RESTful APIs, then you lose all of these things. And you should understand that two sense. If you do you support the business or do you support the player code? So I think it's question is about your boss that should understand that
and
it's middle of the decision. So.
It's a matter of trade-offs.
Yeah.
It's always this. But it's fine. You can move only this part, as I said, it's not RESTful anymore. But you can keep your or REST or HTTP++ API and move this as a RPC thing, and that's fine. But then, you, as I said, you have to tell your boss that this thing is quite tricky and not technically great, even if it works for your customer, and that he should make some pressure or something to say it could be nice to refactor this thing to a better technical architecture.
Thanks, man. Very thanks. It's really cool.